Suppose we go look at the main program here for a second. Oh, that was the awful one. Just going to look and see if I have an actual little main program. That's not the one. We'll do it in the test. Or better yet, let's just write a sample quick main program. I'm going to steal a bunch of my data here. Nah, let's write a separate test. I'll do a unit test since it looks like a main program anyway. Suppose we just wanted to do something like loop through all of the items. I'll just make a new chained list. And just because I'm in a hurry, I'm going to go down and do it the slow way. Take all of those things. Add them into the list. Suppose this were an array list, and I wanted to use an iterator. What would the iterator code look like? Not a for each, but go back to using an iterator. What was the first thing that you did if you wanted to use an iterator directly with array list? We had something like iterator, go make an iterator, and then talk to the array list, which is workers, and say workers dot go get me an iterator. Fetch me somebody who will help me go through all of the things that are on the list. Then what did we do next? We had that while loop, while iter dot has next. We would do worker who equals talk to the iterator and do a dot next and then print it out. Okay, so it looked something like that. So since we're building our version of a list anyway, and we said we want it to work sort of the same way that array list does, only for a chained list, it would be nice if our chained list had this method in it. Okay, so I'm going to go back into our chained list, if I can find it. And let's add the iterator method. Looks something like that. Do the import statement. In terms of the concept, this was go to the warehouse and say to the warehouse guy, go hire me and one of your employees who's going to do the job of helping fetch things for me. So hiring an employee means making a new one. So there's this sense here that if you go to the warehouse, they're going to give you back a new, for want of something else. I'll change the name later once you get the idea. Send me back this fetch employee who's going to be in charge of getting things for me. The joy of this versus putting a variable up here is that instead of this thing remembering just one instance of where are we as I'm going through these things, now we're making a new instance of going through it every time. So I'm going to get rid of this one and just leave the sense that the fetch employee is going to be in charge of remembering where he is somehow. Okay. So down at the bottom of this thing, I'm going to write the fetch employee class. I'm going to make it public because somebody else needs to see it. So now I've got this employee. What information does he have to remember in terms of what's in the warehouse? When somebody says, I want you to start fetching things from the warehouse, where does he start? He's going to need to keep track of where he is in this thing. So he's going to have to stand over top of one of these things that's a node. So it's actually what we already had. Oops. He's just going to have to remember where he's standing. Let's write the constructor. Where should he start? What values should current have? Okay. So when somebody says, go get me an iterator, here's my iterator variable in the main program. That creates a fetch employee object. The fetch employee object is just remembering current variable, where it is, and it sets itself to refer to the same position as the start variable. Okay, so it's now standing at the front of the chain. We'll go back and look at the driver program here for a second. So now we've taken care of the go hire me somebody who's going to do the fetching. We've got that person standing at the beginning of the list. And so now we talk to that person and say, do you have another one? So we need the has next and next methods inside of this iterator thing we just built. So we'll go into our fetch employee and we'll make sure that we've got public Boolean has next to do something, and also public, in this case it's worker, or actually we'll use object because that's what we've been using here. Go get me the next one. So we're playing the role of the person who's standing here fetching things. Somebody asked me the question, do you have another one? How do I know whether I do or don't have another one? If next or current is actually referring to something, then I've got another one. So if current isn't referring to anything, or if it's gone past the end of the list, then current is going to eventually be null. So if current is not equal, if current is equal to null, I've got nothing. So if current happens to be empty, then the answer is there's nothing on the list. And if current is anything but empty, then the answer is, oh, I've got something. How about next? They ask the question, have you got something for me? standing over top of this one? The answer is yes. If they come back and say, go get it for me, what do I give them? This thing, which would be give them back current. Is that the thing you want to give back to them? Remember, this is a node. This is a node. Want to hand them back a node?
No, it's a thing.
What did they give you back? They gave you this thing to put onto the chain. So when they ask for the number 0 thing back, the thing that you're going to give them is not the box that you put it into. You're going to give them back the original thing that they dumped in, the toaster or whatever they put onto the list. So we don't give back current. We give current dot thing is the thing that they originally put on the list. So this thing becomes return not current, but current dot the actual thing that was being stored on the list.
Would it be helpful to also check the Boolean has next there as well to make sure that actually is true?
That's what the main program does.
So you can't call next without first.
You can't call next without doing has next.
Oh, okay, then it's redundant.
And so I just want to get rid of whatever error I've got up here. It's saying an employee who fetches those things doesn't promise to be an iterator. What do we have to do to fix that? So fetch employee, if you look at them down here, isn't making any promises about what kind of thing he is. So what should it be doing? Implements iterator. So that says, I promise to have a next and a has next in my class. Now it turns out that iterators, I've been lying to you a little bit, they actually have one more method that we haven't been writing, which is remove. So it's actually legal to, while you're going through things, to ask an iterator to remove things. We're just not going to write that one. So we're going to lie a little bit. We're going to say, yeah, I promise to do all of these things, and then we're going to do the 12-year-old thing. But if you ask me to do this, I just ignore you. So still meets the standard because you can ask me, but doesn't quite work in all cases, which is fine. Okay, so that solves that little problem, and let's just see what this other problem is. See if it'll. This says you're giving back an object because that's what you promised to return, but in actual fact, we know since we put workers on the list that the thing that we're getting back is workers, and this is missing a dot out to print them out. Okay, so now let's look what happens with this loop. Let's just redo our diagram. We've got something that looks like this. The main program comes along and says, there's my iterator variable, and it calls the chained list and says, I need somebody who's going to help me go through these things. The chained list says, oh, that's fine. I'll make you one of these fetch type people. So there's make me a new fetch object. The fetch object has only got one variable. That variable takes the value of the start variable, so it positions itself to the start of the chain. Okay? So think of anything that says current as standing on underneath this node. Now the loop starts, and we talk to the thing that says, here we've gone and gotten the iterator. Now we turn around to the iterator and say, hey iterator, you got anything for me? Call the fetch thing, you got anything for me? The answer is, well, yes, I'm standing underneath one right now. Okay, loop now says, could you give that one back to me? Says, oh, okay, there's the one you want. What should the iterator do after it's given you back this one? You don't want that one anymore the next time.
Go to the next one.
It should take one step forward. So the thing that we're missing in the iterator code here is when you call next, it's not a matter of returning thing to store, but you have to also advance. So someplace along the line, we're going to have to do current equals current dot next to make it advance, or current equals current dot whatever I called it, get next. Unfortunately, that now breaks our code since we advance before we send back the thing we were standing over, so we're always one ahead of ourselves. So this is this trick that we almost always play here of saying, oh, let's just remember the interesting one first. And then return that item. Okay, so this is Pfeiffer's rule, always write the thing you want to get at first that you're planning on returning. Oh, there's the thing I'm planning on returning. I'll return that item when I'm done, and then in the middle I have to remember to now advance to the next position. Okay? And so what this does is it says, oh, the one you're interested in is that. I'll remember it. Now that I've remembered it, I'm going to slide this variable to now stand over top of that one. And now what happens is the next time you go through and say, got anything else for me? Oh, I'm still standing over top of something. When they say, go give it to me, oh, okay, I'll give you that thing, and then I'll slide this thing to stand underneath that one. How many times does this guy go through the list? Basically just once, right? This loop, now every time you call the iterator, it's just advancing down the list through all of the items once. Versus if we do this by calling get, it's always resetting itself, and so it's advancing down the list n times for every n things that are there. Okay. So, if you write this piece of code using an array, you'll get really, really efficient performance. If you write this piece of code and you've got a chained or linked list underneath that's doing the work, this is really, really bad performance because this is n squared. The way you fix that is to not use a counted loop, but to use an iterator, because now an iterator can literally position itself underneath every single item on the list and just move down the list once, and it always remembers where it left off. And now this thing becomes efficient. Okay? So the bottom line of this is that if you always use this piece of code when you go through lists of things, it doesn't matter whether you're going through a list with an array underneath or a list with a chain underneath, they both have the same performance. What does that iterator convert into eventually? What do we use that's the next level up rather than writing all that crud ourselves? A for each. And so here's another bottom line. Since a for each uses an iterator, you're better off to always use a for each to go through things, because that means the iterator can take advantage of the guts of the thing and speed up the performance, whereas a counted loop can never do that. You're stuck with however it happens, the architecture or however it happens to work inside. Okay, so this is another reason why we always prefer for each before we resort to iterators, before we resort to counted loops or while loops. Because in general, they will do better performance things for you than just using a regular counted loop. This was an iterator for a chained list, and it had to remember a node. If we write an iterator for a loop or for a list that's got an array underneath, what does the iterator have to remember in the array case? There's no nodes in here. In an array case, you've just got 0, 1, 2, 3, 4, 5. So what's the iterator remembering?
Just remembering the number on the list.
It just remembers what number you're at. So if you say, get me the 0, 1, it says, oh, there's 1 there. Get me the number 1, get me the number 2, until eventually it says, oh, there's nothing there anymore, you've run out of items. So it turns out there's no advantage to using an iterator directly in an array list other than that it remembers the number for you. There's no performance advantage because there's no difference in performance when you get the 0 position, the 1 position. Get is a really fast operation. But in order to use either one of these interchangeably, you're better off never to use positional notation and always use a for each. Always faster. Got it? For the next lab, I'm going to make you work with this code, with the chain list code. So lab 3, 4, and probably 5 are going to be various problems of doing things with this chain of things just so that you get used to working with linked lists. And I guarantee it's the one thing that you're going to be kicking and throwing things to try to get it to work. Typically sort of difficult to work with. Okay, questions about linked lists and iterators so far? What's the problem with this code, the way we've written it, in terms of using big O object? We've got to do this cast to worker. What happens if I do this? I'll do it this way just so that you see it. What's going to happen when it runs the loop?
It's just adding a string, it's not adding any. It's going to try and typecast the string to a letter.
Yeah, when it retrieves this last item, the thing that's coming back is a string at some point, and we're going to reach this line, we're going to get a string back, and we're going to try to say that a string is a worker. What's going to happen when you do that to your code?
It's not going to put it on the list because there's no number there.
What's actually going to happen when you run that loop?
Yeah, it'll cause an error.
What kind of an error?
Invalid character
Specifically. Now, what kind of an error when you try to retrieve it and it tries to do that cast? Is your program going to continue running? Put it that way.
No.
It's going to die because you can't convert a string to a worker. There's no way. Okay? And so the problem with using the capital O object here is that it works fine for being able to store anything onto a list, but as soon as you're allowed to store anything onto a list, you can mix and match the types of things that you put onto a list, and then if you accidentally put the wrong type of thing on someplace in your code, it's not until you go and retrieve them, possibly quite a bit later, that you all of a sudden have the code die on you. And now you have to go hunting through the various pieces of your code trying to figure out where did I put that silly thing onto the list. What did we do to fix that in ArrayList? what did we write on that line? We changed this thing to use the angle brackets here to put the word worker in there to say, I'm going to only put workers on this list. If you try to put something else on, I'm going to warn you right away as soon as you add it. So it's a compile time error to try to add string on in that case rather than a runtime error. Okay? So the next step in our life of building something that does the same thing as ArrayList does, or in this case a chain list, is to try to figure out a way to get those angle bracket restrictions on there. So now we get to look at the magic of angle brackets. Now, just to make your life easier to start with, rather than worrying about angle brackets for this chain list, let's go back and look at the simpler code that we have for object list. Let's see if I can get rid of some of this crud here. So I'm going to go back to the array version here for a second. Okay. And we said that we'd written chained list and object list so that they were essentially the same thing. So I'm just going to put this back to being object list and put this back to being object list. Okay, so there's our example with using an array of things. Let me just bring up object list again so we can see it. So now we've got object list with an array of things underneath of it. The code that we did the week before last. Okay, let's add the angle brackets. Object list, if we want it to work like array list, we should say this thing can only have workers, and we can say that portion should only have workers. And we get a syntax error because it doesn't understand that angle bracket notation yet. The way that you add the angle bracket notation is you go into the object list class and we say object list is now something that can deal with angle brackets. Okay. Now here's the sneakiness. The question is, what do you put in those angle brackets? Okay. Now, remember when we had this thing as a worker list? Before we changed it to object list, this said worker. Every place we had object, we had worker. Okay, and all that we did to change this to object list was we just took out worker and said we'll put object in its place. I'm going to sort of go back the other way for a second. I'm going to change all of these. I'm going to think about if I were to change all of these to worker, what I would do is think of it as saying, oh, I'd like the word worker to appear here, and then every time I had object, I'd like it to say that instead. Okay, so basically just do a substitution. Well, instead of saying worker, I'm going to make this a variable, and I'm going to use the word e here as a variable. And just let me finish this off for a second here. So basically every time I say object, I'm just going to call it e instead. Oops. Call this one e. Here's another one. I'm going to call that thing e. Oh, by the way, this isn't one that you want to do refactor rename on. So there's, I found the word object. I'm going to change it to an e thing. I'm going to change this thing to an e thing. Let's see how many more of these I can find. There's an e. And I think that might be all of them. See if I got them all. Yeah, pretty close. We'll worry about those in a second. Okay, so don't worry about the error for now. If we go back and look at the driver program, all that's happening is when you take that word worker and you pass it into object list, this E thing up top now gets a substitution for worker, and that means every time you see E anywhere in this code, think worker. It's just literally like a search and replace of the E with the word worker. Okay? So if I change this thing to object list student, then inside this class, E becomes student, and anytime you see the word E, just think student. So it's just really a substitution. That's all there is to it. Why are these errors here? That's a strange Java-ism. Okay? We'd really like to be able to make a new array of whatever they are, workers, students, whatever is being substituted for E, but the syntax doesn't allow that. And so, just to be quirky, what you have to do instead is you always have to make an object array, but now you have to do the cast and say, no, 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 it's not an object array, it's an array of E things. So an array of workers, an array of students, an array of whatevers. That's just strictly a stupid Java syntax thing. Okay, and so we'll fix that and hopefully fix the other ones. So I'm going to go down here and I'm going to make this a new object array, and I'm going to say this is really an E array of things. To fix that one. This one is just because of something we've done wrong in our interface, and so I'm not going to worry about the interface for now. So pardon me if I just wipe out this interface because it's got some other stuff that I don't really care about at the moment. And remove the @overrides because they're just going to cause me an issue. So we're not overriding anything at the moment, just to get the syntax out. And there we go. Okay. Now if you go back and look at this program, that's a happy camper. If you want a list of strings, here's an object list that can only hold string type things. It can only hold string. There's the creation of it, and then you can go string list dot add some string. And notice now with the angle brackets, I can't do a list dot add some string, because now the error message, because we put the angle bracket syntax on there, says no, 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 you said that list was going to contain workers, you can't put a string on it. And so now it catches the problem of adding the wrong thing at compile time rather than at runtime. Because of that, you no longer need to do the cast here, because it knows that the only thing that can be on that list is workers. Okay. So now we basically got a complete array list equivalent. It's got the ability to add items. It grows whenever the list needs to grow. It understands the syntax for the angle brackets. We could put an iterator on it to make it do a for each. We've built essentially almost all the stuff that's in ArrayList except about the other 90 methods that ArrayList happens to have. and you know how it works underneath. If we were to do the same thing on ChainedList to add the E notation, it's just slightly more complicated because of the silly node thing in there, but it's still going to be ChainedList of E-type things. And now we're going to add an E-type thing, etc. And we do all of those same sorts of fixes to this one in order to get it to do the angle bracket thing.
Question, I guess it's kind of going back a little bit, but when you declare the max items that the list can hold, why do you declare it private static final when you're intending that this number can change if it needs to?
That's a constant. It changes by the fact that afterwards it initially gets made with that size, but then when you grow it gets made based on the size of the existing array. So it's only a constant when it's first created, and then after that we ignore it.
So why bother having a constant if you're just going to change when you need to?
The reason for having a constant is twofold. First of all, it gives it a name rather than a number, so people have some sense of what you're using it for. And the second reason is that if you use it, sprinkle it throughout your code in a whole bunch of places, then by giving it a name, you only have to change its value in one place.
I think the question is, why is it final if you're going to change it anyways?
This thing is final, but this is a constant. You put final on constants to say, I don't want you to change it. After that, it's not based on that constant. After the first time, it's based on the size of the array afterwards, the current number of items in the array afterwards. Okay, that just happens to be the standard syntax for declaring a constant in Java. Okay, so we've reached the point now where we can do everything that ArrayList can do, and we've now got an interchangeable chained list. So now the question is, when should you use ArrayList versus when should you use the chained list?
If you're looking in the middle of that?
Remember, because we know.
So in general, where did ArrayList suffer in performance from Lab 1? Deleting from the beginning, also inserting at the beginning.
Yeah.
Because if you insert, then everybody has to shuffle down in order to make room.
And slowly.
So if you ever have a problem where the thing that you're doing is you're using a very long list and you're always adding or removing from the beginning, then you should use the chained version instead. And by the way, in actual Java, the chained version of this thing, instead of being called ArrayList, it's now called linked list. So before, where we had done list of worker my list equals new ArrayList of worker, the built-in one is now, just let me get the import statement there. The import, and we'll do this import statement. So there's the list with an array underneath. In real Java in the libraries, if you want the chained version or the linked list version, it's appropriately called linked list instead. And there's the interchangeable equivalent that we built for our second list. Okay, so ArrayList has an array underneath in Java, linked list in Java, and the library has a chain underneath it of things. You can use either one depending on the performance that you want, depending on the type of problem that you've got. And we're done with lists for the moment. What we're going to do next is we're going to go through, in the next week or so, we're going to talk about stacks and queues. and you sort of already know what they are, but what we're gonna do is we're gonna brush up on our ability to do arrays of things and chains of things by making a stack and then trying to do it with an array, then trying to do it with a linked list, right? Making a queue, trying to do it with an array and trying to do it with a linked list, okay? And that will help with the concepts of using an array or using a linked list to have seen it over and over and over again. So if you didn't get the linked list the first time through, you're gonna see it the second, the third, and the fourth time through until it becomes a lot easier to do, including some lines. And with that, I'm out of here for today.